Hello everyone and welcome back to my channel Teacher Sneha. In today's video, we are going to solve an extended math past paper question which you can already see on my screen. Plus, you will see the original question from the question paper on the right hand side of my screen. So this question was asked in the paper May-June 2022, variant 41, and this is question number 5B. In question 5b, the first part of this question asks us to calculate the volume of given figure. As you can see, this given figure is half of a cylinder. So to calculate the volume, what we have to do is, we have to calculate volume of cylinder. So volume of cylinder is pi r square h. This is the formula. And since this is half of the cylinder, we have to divide it with 2. Now here h could be the height of the prism, or h we can take it as prism length also. So as per the given information from the question, this is going to be pi. Radius is given here as 0.45 meters. So pi multiplied by 0.45 multiplied by 0.45 multiplied by height or the prism length, which is 4. This entire thing divided by 2. Now to solve this, I'm going to make use of a scientific calculator and I'm going to put all these values here on my calculator. You will see how I have written this on the calculator on my screen now. The calculator screen shows answers up to 9 decimal place. Since in IGCSE papers, we have to write answers up to 3 significant figures, I will write my answer as 1.27 meter cube. All the values are given in meters, and since we are calculating volume, the unit appropriate is going to be meter cube. This is how I have solved first part of this question. Now let's focus on the second part of this question. The second part of this question gives you a figure like this, in which they have shaded the region in the cylinder, which is continuation of question number 5b1. The half cylinder, if it is filled like this from bottom up to the height of 0.3 meter, how much will be the volume of water inside the cylinder? That is what the question is. So the given information is a cross-sectional area over here, which shows that 0.3 meters of the height. They have shaded that region to show that that much is the cylinder filled. And now we have to calculate the volume of water inside the cylinder. Firstly, we will be using formula. Volume is area of cross section multiplied by prism length. This is the formula which we will use over here to calculate volume of water inside the cylinder. Second thing, now what we need after this is, we need area of this shaded cross section, which we do not know. So we have to calculate area of this region. Now the question arises, how are we going to calculate area of shaded region? To calculate area of shaded region, what we need to know is, we need to know the area of entire semicircle. From the semicircle, if we will subtract the area of the top white part, which I have not shaded, we will automatically get area of shaded region. So area of shaded region, we are going to find out by finding out area of semicircle minus area of white region. White region is the region which I have not shaded. Now if you will closely observe, this white region, it's a part of a curve. The edges of this white region are curved edges. They are not smooth edges. It is not a rectangle. It resembles to a rectangle, but it is not a rectangle. So how are we going to obtain area of this white region? This is a continuation question of 5b1. In b1, the figure has shown that the radius of this particular cylinder was 0.45 meters. So from 0.45 meters, if I will subtract 0.3, this whole thing was 0.45. I subtract 0.3 from that, and what I will obtain over here is 0.15 meters. So this is the height of the remaining region where there is no water. The other construction that we need to make over here is we need to divide this region into two parts. So the region below here is this region which I am shading here is a right angle triangle, because this particular angle is 90 degree, it's perpendicular. So this is a right angle triangle. Similarly, we will obtain one more right angle triangle on the other side as well. We have to find out area of these two right angle triangles. At the same time, here we obtain a sector. We have to find out area of this sector and area of the sector on the other side as well. So when we find out area of two sectors and two triangles, if we subtract it from the area of semicircle, what we obtain is area of shaded region. Now to how to obtain area of shaded region? We need area of white region, as I told you. And how are we going to obtain area of white region? I'm going to write that as well. So area of white region is area of two right angle triangles plus area of two sectors. All of these calculations we need to do in order to obtain area of shaded region. To make it easier for you to understand, what I'm going to do is I'm going to write down all these required information here on the corner of my board, and then I'm going to continue to solve it part by part here. To make our calculations even more simpler, what I have done is I have converted all of these measurements into centimeter, and now henceforth we will be using the values in centimeters to calculate all of these given things that are required. First, we are starting with area of right angle triangle. Area of right angle triangle. The formula for this is half into base into height. So we need to know half into the base EF multiplied by height, which is BE. To calculate EF in the right angle triangle BEF, we are going to use Pythagoras theorem. Using Pythagoras theorem, EF, which is the base side over here, and BF is the hypotenuse. So EF square will be obtained by BF square minus BE square, and after solving, we get the answer as 42.4 centimeter. I'm going to use this value of EF to put it here in the formula of area of right angle triangle to obtain the answer for area. So half into 42.4 multiplied by 15 gives us the answer 318 centimeters square, which is area of one right angle triangle, which I have marked here. Now to obtain area of two right angle triangles, what we have to do is 318 multiplied by 2, which gives us the answer 636 centimeter square. We will note this down here. Here we are done with first step. Now what we have to do is we have to calculate area of two sectors. That's going to be our next step. If you want to note down this working in your book, pause this video here and note this down in your book. In the next step of this sum, we are going to solve area of sector. So area of sector, we know the formula as theta upon 360 into pi r square. This is the formula for area of sector. Now in this, this particular angle which I have marked is the angle theta, that is angle CBF. So theta is angle CBF. How are we going to calculate this? Let's see that. Since we need to calculate angle angle CBF is complementary to angle EBF, the angle that I have marked over here or highlighted over here with black color. So this is the angle in right angle triangle to which this angle CBF is complementary. How are we going to calculate angle EBF? By using principle of trigonometry, angle EBF can be worked out by cos ratio. So cos inverse of BE upon BF. BE, this side that is adjacent to this highlighted angle, and BF is the hypotenuse. So by using cos inverse of BE upon BF, which is adjacent upon hypotenuse, I can work out angle EBF. And then if angle EBF's value, I subtract it from 90 degrees, I'm going to get answer for angle CBF, which turns out to be 19.47. I have put this entire equation on my calculator to obtain this value. The calculator working is now on your screen. After I have obtained angle theta, that is 19.47, area of two sectors I have to work out. So area of two sectors will be 2 times theta upon 360 pi r square. After substituting value for theta as 19.47 that I obtained here, I get the answer for area of two sectors as 688.13 centimeter square. So the answer for the second thread of our working is also obtained. That is 688.13 centimeter square. So here we are done with two stages of our working. Now let us figure out area of semicircle. And before that, please make sure that you note this working in your book. So pause this video and note this down in your book. In the last and the final part of this sum, we need to work out area of cross section, which is nothing but area of shaded region. Shaded region is this region which I have marked with green color. And how are we obtaining that? That by doing area of semicircle minus area of white region, or you can say the top region which was not shaded. Now since we have obtained the area of white region, by adding these two areas, that is area of sector and area of two right angle triangles, area of semicircle, which is the entire semicircle, can be obtained by pi r square divided by 2. And when from area of entire semicircle, I will subtract the area of white region, what I obtain over here is area of cross section or the shaded region, which is marked in green color. So that is 1856, that is 1856.73 centimeter square. The calculator working is now on my screen. After doing this, we have to figure out volume of water. To calculate volume of water, the formula that we are going to use here is area of cross section multiplied by prism length. Since we have converted all of our measurements into centimeters, 4 meters converted to centimeters becomes 400, and area of cross section we carried it forward from top. After multiplying these two numbers, the answer that we obtain here is 7,42,696 centimeter cube, or you can say 742,693 centimeter cube. This is what my answer in centimeter cube is. But the question is asking us to convert our answer into liters. To convert that into liters, I will divide it with 1000. Why I have divided with 1000? Because 1000 centimeter cube is 1 liter. Using this equation over here, these many centimeter cubes divided by 1000 will give you your answer in liters, which is 742.693 liters. I have to give my answer to nearest integer. So rounding off to nearest integer, my answer comes as 743 liters. This is how step by step we reduce the volume of water. Now pause this video and note this working in your book. Here we have completed solving this question. I hope you have liked my explanation and it helped you to understand the complexity of the question and it helped you to understand how step by step we will derive our answer. If you have really liked this video, please consider giving this video a thumbs up, and if you are new on my channel, not to forget to subscribe to my channel. Stay tuned and I will be posting more and more videos of past paper questions. So whichever question you are finding it difficult, please write that down in the comment section of this video so that next time I will come up with a video as a solution for your question. Thank you so much for watching. Have a good day. Bye bye.